Hi, this is Perception Part 2, probably day 3. Okay, this is important. So, there are our brains maintain constancy, and they all seem to be the same. So, if you want to save some writing, let me just explain this to you. Shape constancy says this: if you look at something from a different angle, your brain keeps the same shape. Like, for example, when a door opens, the image on your eyeball, your retina, becomes a trapezoid. However, in your mind, it's still a rectangle. The Imagine if the door changed into a trapezoid and you thought, "Oh my god, it's a trapezoid." But no, your brain knows that it's still a rectangle. So that is what we mean by shape constancy. So even if we look at a certain shape from a different angle, our mind still knows that it's the same shape. Same thing with size constancy. Just because something is going away from us or coming towards us, we don't think that the size is changing. We're not looking at this car going, "Oh, the car is becoming smaller." No, of course not. And when a car is coming toward us, we don't think that the car is getting bigger. The size stays constant. Our mind knows better. And we also have color constancy. Okay, which I don't have a visual on that, but how about if you're looking at a blue toy and then the sun is starting to set and then the toy becomes a little bit gray, you know that the toy isn't changing color. Your mind still perceives it as the same. So we've got shape constancy. Our mind keeps the shape in our mind. Size constancy. And we also have color constancy, which I don't have a slide on. Okay, because this stuff really confused me. I'm starting to get it now, but this stuff really confused me. All right, let's try some questions. All right, read that. The answer is all right, so the car is going away, and the image, although the image has changed, you still see the cars as identical. Since the car is going away and the size on your retina is changing, this will be size constancy. Okay. All right, try this one. So you don't perceive him to be shrinking. The answer is size constancy. So his size is staying the same, even though he's walking away from you or driving off. All right, read this one. Which of the following is an example of shape constancy? All right, the answer is, make sure your answer is about shape and not, say, a color or size or anything. The answer is A. All right, B is color constancy, C is color constancy, D is something else. Okay, all right, moving right along. All right, read that. All right, so we're dealing with color orange. It's color, so the answer is B. I hope I didn't ruin that for you. Moving right along. All right, I've only seen this once on the AP exam. If you want to write it down, great. I'll probably give you a question on it. I don't know, but the Mueller-Lyer illusion. I do believe it's Mueller because it's got two dots in front of the U, so it's like a German name. This is an optical illusion. It's a classic. And I do write this down because I realize this is important. I'll explain to you why. The illusion is this: the vertical lines are equal length. If you don't believe me, measure them. Like, hold up a pencil or your finger or something to the screen. They are equal length, but they seem to be different lengths. Okay? Why do they seem to be different lengths? Well, I've got a slide that'll explain it to you, but just acknowledge the fact that this one does seem a little bit longer than this one. Why is that? Well, let me give you, I have it on a different slide. By the way, I want to prove to you that they are the same length. Okay. Now, this next slide will explain it. The figure on the left seems to be a closer, since it looks like an outside corner thrust towards you, whereas the figure on the right looks like an inside corner thrust away from you. Given retinal images of the same length, you assume that the closer line is shorter. I honestly don't understand this, I'll be honest with you, but I do understand this concept. If you grew up in a yurt in Mongolia, where you did not grow up in rectangular housing, you grew up in a round tent, this illusion would not work for you. If you go to Mongolia and ask people who grew up in round tents, like which one is bigger, they would always say they're the same. They would not fall for this illusion. So the concept that I'm trying to teach you is this: your background, your culture, and your expectations make a difference. Okay? So, given what I just said, do this question. The answer is expectations. Think of perceptual set, okay? Think of it that way. But it's also a little bit cultural. Okay? All right, moving right along. This is called the Ames room. I don't think it's on the exam, but it's kind of interesting. It's a room that kind of messes with your perception. It turns out that the person on the right is much closer to you than the person on your left. And also they do other things with the ceiling and the floor to mess with you. All right. This is on the test. Context effects. Context matters. The surroundings matter. Write this down. I'm going to explain it. All right, so here's a famous, I guess it's an illusion, I don't know. Which of the orange circles is bigger, the one on the right or the one on the left? Well, and some of you know, and that's okay, but they are the same size. Okay? And if you don't believe me, put your finger up, give it some scale or something like that. But again, the context matters. What surrounds it matters. That's called context effects. So if the key is you don't need to lose weight. You just need to get fatter friends. Okay? If you want to look thinner. Okay? Now here's something. Buffets. Did you know that buffets use smaller plates? They do that because they want you to eat less food. Saves them money. However, if you go to a nice restaurant, they always give you big plates. Why? Because psychologically, it feels like you didn't eat as much. That's true. So big restaurants want you to order appetizers and desserts. Buffets want you to stop eating as soon as you can to save them money. So if you ever want to eat less food, eat on smaller plates. It does help. It's all about context. You remember this? Well, what you see in the middle depends on the context. Is it A, B, C, or is it A 13th C? You see, it depends on what the context is. 12B 14 or 12 13 14. Right? It depends on the context. How tall is tall? It depends on the context. True or false? Both center patches are the same shade of gray. The answer is true. They are the same. You don't believe me? They are the same. But it's the context that makes them seem like a different shade. I don't know what to say about this, but I just think it's really cool. It's all about the context because of that shadow that you see. But they are the same shade of gray. That one trips me out. All right, one more time. All right. This one is weird. It's kind of an illusion. All of these balls are the same color. They are all brown. They are all the same color. The only thing that's changed is the context, the color of the lines. That changes. But all of the balls are the same color. All right, moving right along. Pause if you want to, but moving right along. This one is really weird. This is a black and white photo. I know that's crazy, but this is a black and white photo. What changes are the colors of the lines. Okay, moving right along. If you hold your finger up and cover this middle portion here, A and B will be the same color. I know it's crazy, but it's true. All right, moving right along. All right, do this question. The answer is A, the context. All right, read that. The answer is B, perception is in your head. Okay. All right, just a fun optical illusion. What's weird is that all of the lines are parallel. At least the ones that are going left and right, they're all parallel. But we don't perceive it that way. Okay. All right, that's enough. Thanks.